All right, this is Geometry, Review 1 through 35, Part 3. The school year is 2020-2021, first period class. Question number 6, we're going to pick up from here. Just going to talk about the law of syllogism. Syllogism was dealt with in the last question. It was dealt with in terms of looking at states and regions and things like that. This question is going to look at things more mathematically. The important thing here to remember again is we're looking at things like if A, then B, if B, then C, therefore if A, then what? Then C. Okay. Now it doesn't always work out exactly like that. Okay, but that's the basic principles that we want to connect every major component of a statement to the other components, right? And there should be 3. Okay, there should be 3 components. So if they gave you something along the lines of, let's see, something along the lines of if 2 lines are perpendicular. Okay, if 2 lines are perpendicular, then they meet at 90 degrees. Is that a true statement? Yes? Okay. So I would, if I'm working this question or even showing my work on my paper, I want to underline some things. I want to label those things. Okay. What could I underline and label? What's the important part to, or there should be 2 important parts listed in that statement. Okay. Let me go ahead and give you the next sentence and see if it doesn't jog something here. Okay. If 2 lines meet at 90 degrees, then they form right angles. Okay. Our last statement, we'll say something along the lines of 2 lines meet at 90 degrees. We need to make a conclusion. Therefore, what? Well, let's see. It looks like maybe I need to change this because 90 degrees is already associated with everything else. Let's say let's say 2 lines are perpendicular. Therefore, what? I've already said that though. Don't we already have that? What's that? Okay, so how can we be sure not to make a mistake? Because you might have written in there 90 degrees, right, and gone on with your day, right? Because I'm not going to be there for the test. All right, is there a way I can be sure not to make a mistake? Thoughts? I'll let you guys think about it for a second. Remember what I drew up there in red just a little bit ago? Did I draw complete statements or did I draw just letters connected to other letters? Just label them, okay? Good. All right, how can I label some of this stuff? Can I underline anything? Is there anything that like sticks out in that first sentence that I know that I'm going to use? That's the whole thing though. I want to look at just like one specific thing. Perpendicular, okay? Perpendicular. Can I label that as anything? A, good. All right, now we're cooking with gas. Now what? What else in that statement can be underlined? How about just, yeah, 90 degrees. What would you label that? B, okay? Okay, look at the next one. Any new information there? Right angles. What are you going to label that? C, right? And if you wanted to, right, we see B. So far what we see is we see that A equals B, right? That's what we see in the first line. Then what? What do I see down here? B equals C. All right, and what do I see? Let's look at the last sentence. What can I underline in the last sentence? Perpendicular. What is perpendicular? A. A. What should A equal? C. What is C? Okay, therefore, they meet at right angles. So you were right. I wasn't trying to suggest that you weren't right, Tiffany, but if I want to make sure that I'm right, okay, it helps to label and draw things up, okay? So because, yeah, you wouldn't be wrong technically by saying, you know, if two lines are perpendicular, then they meet at 90 degrees, even if it's a statement that's already been listed. But we want to follow that transitive property, that if A equals B and B equals C, then A equals C. Does that make sense? And this isn't exactly how it is on the test question. So you need to underline those important parts, label them, and then make sure that everything is connected the way that it should be. Okay? All right. Yeah. It's going to give you everything except what I have on that last part in red. You have to come up with that, therefore this is true, right? And it's going to give you a bunch of statements that are technically correct, all right? But it's looking for the one that's needed, okay? It's looking for the C. All right. Let's see. This one it's going to give you some coordinates, and it's going to ask you to graph and find the area. So let's see, graph. And find the area. Okay, so let's see. Now, the nice thing is that all the graphs are going to be the same. Okay? They're all going to give you the same figure. They're not going to be located in different places. All the graphs are going to have it in its nice, neat spot. Okay? So it'll give you something like something like that. Okay, they're going to give you 4 coordinates, and you have to find the area of the figure. Okay, again, if for some reason I got rid of all of the multiple choice options and you had to graph this yourself, what do you need to ask for? Graph paper. Okay, do not try to freehand it like I'm about to do. Okay, because there's just too many ways to make mistakes. For one, I still have students that flip-flop their x and y's. Okay, so -3 means to the left 3, down 3. Okay, I got -3, 0. Okay, I've got -1, 0, and 2, -3. So I get a figure that looks like that. Okay, what shape is that figure? A trapezoid, thank you, very good. All right, how do I find the area of a trapezoid? Anybody? Now this is what's being tested here because they're going to have that picture for you. You have to know how to find the area of a trapezoid. Yeah, so we can either multiply that by 1/2 or we can divide it by 2. It's the same thing. Okay, what is base 1? Bella, you're on a roll here. Any ideas on base 1? Oh, no length is ever going to be negative, right? It might be in a negative quadrant. We might work with negative numbers, but length is always positive. Anybody else? Jordan? Base 1. What do you think? 2. So you're counting 2 across here. 1, 2. Okay. Let's see. 1, 2, 3, 4, 5. Yep. Okay. So, sorry. 2 plus 5. Okay. What's the height? 1, 2, 3. Okay, 3. Okay. 2 plus 5 is 7 times 3 is 21 divided by 2 is 10.5, right? Units. Just units or units squared? Units squared. Okay, can you guys do that? So this is the dominant thing that you need to know. Okay, base 1 plus base 2 divided by height, or sorry, times height divided by 2. Okay. All right. Let's see, for this next one, they're going to give you a circle. They're going to give you the radius. They're going to tell you that the radius is, let's say that it is 9. And it is, we'll say that this one is in meters. Okay, we want the circumference. And the area. We're going to use 3.14 for pi. So there's no confusion over what our numbers should be. Okay? Now, I'll warn you that if you don't know the difference between your circumference formula and your area formula, there's going to be options where both numbers are technically correct, but they're flip-flopped. They'll have the number for area in the circumference spot, the number for circumference in the area spot. If you select that and you have it wrong on your paper, it's going to be wrong. Okay? So you have to know the difference between your circumference formula and your area formula. Okay? They look very, very similar. Okay? But when you think of area, areas, units are always what? Squared. So what should my formula be? Pi r squared. Okay? Okay, which means circumference is what? 2 pi r. Right? So if I can remember the area squared, so it's pi r squared, right? I'm got an advantage there. So on this, it's 2 times 3.14 times what? Times 9. Over here, 3.14 times 9 squared. I don't know. I mean, you guys can do that all on your calculator. That's not the same number that's on the test. So whatever the decimal comes out to is really not as important as the fact that you know that circumference is 2 pi r. Okay, and area is pi r squared. Okay. All right, we'll move on to number 9. Okay. I don't know that I'm going to spend a lot of time on number 9. Number 9 is a proof. All that's needed for it, though, is that you need to accurately give the reason side. So they're going to show you math on the left-hand side. You have to have the correct reasoning on the right-hand side. Let's see. It doesn't look like anything. There's only 2 parts to it, right? You only have to know 2 reasons, so you just have to be able to see what's going on there. Yeah, and then just need to know, and I think that's the same thing on all of them. Okay, so I mean, I'm not. We'll see. Let me try a couple of different things to show on it, though. Let's say that I've got some math up here. We got statement, we've got reason, so just something to practice. Let's say that perimeter of a figure, let's say perimeter of a quadrilateral is 2 times the length plus 2 times the width, right? That's going to be given. Okay. And in this information, they tell me what the perimeter is. Give me a 2-digit number for perimeter. Just 10? Okay. Okay, 10. Okay, so they're going to tell me that the perimeter is 10 in our information, and give me a single-digit number. 5. Okay. So we're going to use 5 for length plus 2w, but that's all the information that we have. We need to find the width. What would we describe this step as doing? Substitution. Good. Okay, substitution. Does that make sense? Okay. From here, all right, we would get 10. I don't know how this is going to work because can we get a bit bigger number than 10? If we're going to, I mean, because we've already kind of got 2 times 5 is 10, right? Which means my width would have to be 0. Let's try like 28, something like that. Okay. All right. So what would we call saying that this is 10 plus 2w? Simplify. Good. Okay, what do we do after that? If we're trying to solve for w. Subtract 10 here and here. Okay, what do you call that step? Subtraction. Why subtraction property of equality and not just subtraction? Because we're subtracting on both sides, right? Okay, subtraction property of equality. Then the next thing is what? What's 28 minus 10? 18 equals what? 2w? Okay, what do we call that step? Simplify. Okay, now what? Divide by 2. Divide by 2. What's that step called? Division property of equality. Okay. All right, now I'm getting what? 9 equals W. Okay. What do we call that? Simplify. Okay. W equals 9. What is that called? What's that? No, it's not given. Okay. That is referred to as the symmetric property of equality. Okay. And what we would say is that the width is 9 feet or whatever our units are that we're working on. Okay. So there's a couple of things, yeah, that you want to be able to see in all of this because you're going to get something similar on your test. Okay. All right. Number 10. Okay. Here we want to be able to determine if the triangles are congruent. They're going to show you two different triangles oriented two different ways. Okay. Okay. Are those two triangles congruent? No. Why not? Because 10 and 9 are not congruent. So we would be using side to side to show congruency here. These are just simply not congruent. Okay, that's it. That should be maybe the easiest question on the test. You're just looking at all three sides, making sure that everything lines up. Okay. It's the measure of arc AC. (92°). 92 degrees is correct. Because angle ABC is a central angle, the intercepted arc, which happens to be AC in this case, is going to have the exact same degrees as the central angle. Okay? So it should be really easy. Okay, any questions there? All right. 12. Is another proof that you're going to have to fill in the blanks. This one does include 1 on the statement side and 2 on the reason side. But again, did you see how easy the last one really was? Okay, they shouldn't be that hard. Okay, you just, I mean, and you're not taking out the 4 multiple choice options. Just make sure that you're careful as you go through them. Okay. All right. Okay. Okay. Let's see. I'll make sure I got everything right here. Let's call this 30 kilometers, and this is 30 kilometers. Let's say this is 22. This is 22. Right. We'll call this A, B, C, D, and O. Okay, and we'll call this 44 degrees for angle C. Okay. So there's a little explanation here, so you want to listen to this because I'm not going to write it up. It says a pilot uses triangles to find the angle of elevation, which is angle A, from the ground to her plane. How can she find the measure of angle A? Okay, so we need to show how the two triangles are congruent, right? And then how we can use that information. Okay, how do we know that these two triangles are congruent? The side lengths are congruent. So which side lengths are congruent? AO and CO are congruent, okay. DO and BO are congruent, okay. So we just use the side-side congruency postulate, is that right? How do you know that? Corresponding angles? Are we told, have I given you any information that would state that DC and AB are parallel to each other? No. There is a helpful piece of information that would finish off our congruency statement. Can anybody show me two angles that are congruent to each other that are not C and A? Because C and A we don't have the information we need. But there are two angles that we do have enough information for. Can you be more specific than the angle O and the one across from it? Angle O doesn't really tell me anything. I don't know what you mean by angle O. Angle A, I can just say angle A because there's nothing else there, right? I can just say angle B or angle C or angle D because there's nothing else there. But at O, there's four different angles. Well, if I need to be more descriptive, how can I be more descriptive of this particular angle that I'm talking about? Could I use 3 points, right, to tell me where I start, where I go, and where I end? That would describe the angle that you're referencing. Angle AOD. Angle AOD is this outside angle right here, right? Because I'm going from A to O to D. Is that the angle that you mean? How's that going to help me prove that these two triangles are congruent? Because those are outside the triangles. So angle AOC. Angle AOC is just a straight line. AOB, okay, AOB, and what? DOC. Perfect. Yes, those two angles are congruent to each other. Can anybody tell me how you know that? How do we know? You're right, but you might be right out of a guess. We've gone over this, I don't know, probably No. We use that to prove that two triangles are congruent, not to prove that two angles are congruent. How do I know that those two angles are congruent? I've drawn it up on the board, gosh, I don't know, a half dozen times, maybe more. How do I know that those two angles are congruent? Give you a hint, it starts with a V. Vertical angles. What do I know about vertical angles? They're congruent, okay? You have to know that, right? It's not going to get any easier, and right? I'm not going to sit here on a test and say, it starts with a V, okay? So, I don't know. I might suggest writing it down, right? Write down. Draw a picture. Show vertical angles. Write down vertical angles are congruent. Do whatever you need to help yourself because we're here to learn something, okay? And you got to make sure that you're learning something. Okay, yes, vertical angles are congruent. Now, is that enough information to prove that these two triangles are congruent? Yes or no? Yes, okay. What's the congruency statement? What do you have? Side angle side, okay? So the two triangles are congruent through the side angle side congruency, I don't know, what is it, theorem, postulate, something like that. Okay. Congruency postulate. Okay. But remember, what we're trying to prove is we need to know what angle A equals. All right. So you weren't wrong in stating that angle A is congruent to angle C, but we didn't know that until now. Okay? How do I know that angle A is congruent to angle C now? I still don't know if DC is parallel to AB. Nope. A and C are not vertical. What if, here, let me help. Triangle ABC is congruent to triangle what? What corresponds to A? C. Okay. What corresponds to B? Or, well, it's not really ABC, is it? It's really AOC. That's odd. Okay. So what corresponds to, this point O on the other side? O, right? CO. And then what corresponds to, oh, I guess it's not really C, it's really AOB. Let me fix this. Okay, triangle AOB is congruent to triangle CO what? D. Okay. So you're telling me that A corresponds to C, O corresponds to O, B corresponds to D, right? And I've just stated that these triangles are congruent. So C corresponds to A, right? So it would be corresponding parts of congruent triangles are what? Have I really done this poorly? Corresponding parts of congruent triangles are what? Congruent. So what I want to state is that A is congruent to angle C through what? Do we not have maybe a shorter way of saying all of that? Corresponding parts of congruent triangles are congruent. Is there a shorter way of saying that? Corresponding parts of congruent triangles congruent. Corresponding parts, congruent triangles, congruent. Corresponding parts, congruent triangles, congruent. What? No, I'm not asking you to come up with a new phrase. I'm asking you to shorten what I've just said to maybe, I don't know, like an acronym. Corresponding parts, congruent triangles, congruent. CPCTC. All right. All right. So by all of that, the measure of angle A is 44 degrees. Okay, guys, this is getting painful. So I don't know if it's just we really just don't want to answer questions or if we legitimately don't know. Okay, but I am fully willing to take as much time and cover as little as possible to get to find out what it is that you know and don't know. Because if I just stand up here and tell you everything I know, you aren't going to do well on your test. Okay, I'll do fantastic. Okay, but you have to know stuff. Okay. All right. You're going to get, I don't know, let's say Tiffany. Okay, Tiffany and Allison. Tiffany and Allison. Probably spell some names up here wrong. I don't know if there's two L's. Got it? Awesome. Tiffany and Allison are driving from the same location. Okay? Okay, they're driving from the same location. Let's see. Tiffany, how far do you want to drive? How many miles? 30 miles. Okay. Tiffany drives 30 miles. Which direction? North, south, east, or west? Okay, 30 miles east. Okay, 30 miles east. Okay, we'll just say straight east. Tiffany, or not Tiffany, Allison, how many miles do you want to drive? Okay, Allison drives 40 miles. You get to pick either north or south. Okay, 30 miles straight south. Okay, how far apart are they? I can do this one in my head. You guys picked really nice numbers. They're not going to pick nice numbers on the test. Anybody know, based upon just looking at it, how far apart they're going to be? I can tell. Are you guys working out the math? It's 50 miles. Have you already figured it out? Somebody know how I know? You guys gave me the numbers. You could have picked anything. What? It's a 3, 4, 5 right triangle. So they start from the same spot, right? All right. So east should be this direction. Okay, 30 miles east. Okay. Allison is going, what, 40 miles south? Okay, from that same location. Okay, when we're asking how far apart they are, we mean that. Okay, just forming a right triangle because we're using cardinal directions. So what theorem do I use? Pythagorean theorem, which is? Okay, what are we solving for here? We're solving for c squared. Okay, so 30 squared plus 40 squared, you get what, 900 plus 1600. Okay, which is what, 2500? What do I do with 2500? Square root. What's the square root of 2500? 50. Like I said, they're not going to use nice, neat numbers on the test, right? They used numbers that came out to a Pythagorean triple. So that's how I knew before anybody had done any math, right? If I know a 3, 4, 5 is a right triangle, all they did was multiply those numbers by 10, right? Multiply 5 times 10, you're going to get 50. Does that work for you guys? Okay. All right, what are we on here? 15. This is, what time you guys are out at 35. Let's go ahead and stop it there. Okay. 15. Okay, so I just need to cover about 6 questions with the other class. All right.